Members, today we are going to look at how to do a chi-square test, goodness of it in R. So I've already set the working directory. You can watch my previous video on how to set the working directory. So I need library read Excel because my data set is in an Excel file format. So my data, let me just call it ICT data, just like that. So my data is this. And as you can see, if I view the data, you already have the data which is categorical like gender, which is male and female, year 1, year 1, year 2, year 3, computer, yes and no, and extra. So we are interested in such kind of data. So doing a chi-square test, I'm going to demonstrate 3 ways of doing it. I'll start with the basic one which comes with base R. So I'm just going using base R. And specifically, this one uses stats package. Yeah, package. So I will just create a table, tab 01, just store in an object called tab 01. And I'm going to use ICT data and the data called gender, a variable called gender, this one here. So I run that and then I print my tab 1, this one. So you can see I have 43 females and 97 male. This one already tells us that males are more than females, but we want to know if the difference is significant, and that's where the chi-square test comes. So let's do the chi-square test. I'm going to store it in an object called chi, and I'll do chi dot the chi-square test, this one of tab 1. So you run that, and I'm going to print the chi, this one, and when I print, it gives me the chi-square test statistic of 20.83, or degree of freedom 1, and the p-value which is less than 0.05. So this one already tells me that the males are significantly higher than females. But there is a way of doing this if you don't know how to interpret this. The good thing is it comes with has a library called report. Yeah, this report library. So when you run it and you just write the word report, function report, and you are reporting the chi, this chi that we calculated up, and you run it, you get this. So you can see the chi-square test of given probabilities, or what we call goodness of fit, of our table 1, which was having 97 males and 43 females, suggests that the effect is statistically significant and large. And it quotes for you the chi-square test, the p-value, the 95 confidence interval. This is how you do it using base R. Now I'm going to show you another way of doing it with a visual, where we are going to use a package using less R package. So if you don't have it, it's very simple. You know how to do it. Installing, you come here on installation, then you type the package lsr. When you are connected to internet, it will come, then you click install. So because I have it installed, I'm not going to install it again, so I ignore this output. So now lsr. So this is library. Let's R. As you can see, it is already installed, so I run it. Now that it's running, I have access to some different function. Now I'm just going to use the simple function of pie chart. So I use pie chart function, which is from less R, and I'm going to plot gender, my variable, and the data is equal to ICT data. Just like that, I run it. It gives me a modern pie chart, what we could call a donut chart. It does the same thing like the other one did. It creates a table, and from the table, it computes the chi-square statistic. This is very good because it gives you a table here. It gives you the visualization. This is the second way of doing this. The third way is what I like because it gives me a lot of statistical details plus the visuals. And you see this limitation, this one has a limitation. It doesn't tell me how many, it just gives me the percentage. So is there a graph that can show me the percentage, the how many, and all this information on the visualization alone? The answer is yes, and thanks to this guy who came up with a package called ggstatsplot. Library ggstatsplot. This one here. So I run it. And now we just call a pie chart function also, but this time it starts with ggpystats. This one here. And I will have my X as gender, like above. Then I have data. Data is the same, ICT data. But because I want both the percentages and the numbers, I'll put this function called label, and I'll just say it is equal to both, just like this. This is enough to give me what I want. So it takes some time. Now it comes. Look at this. I want to compare with the previous visual. 43%, 43, which is at 1%, 97, which is 69%, male, female, goes ahead and gives me chi-square goodness of it. You can see GOF, degree of freedom 1, which I have the same here, and the p-value, which is the same here. The number of observations, 140 here, and it goes ahead and does the Pearson's coefficient of 0.36 and the confidence interval, 95 confidence interval, the same that we got earlier. So this one gives you everything, all the statistical details on the graph, which is so far the best. So with that, we can end here, then we shall look at the chi-square test of independence that deals with two variables. Thank you.